Hello students, welcome. Previously, lesson 20, form 4, topic 4. We were dealing with qualitative treatments of electrolysis and we were doing Faraday's first law of electrolysis calculations, and we have done aim number 2 or aim number B, which was determining the mass of substance deposited. So today, lesson 21, we want to proceed to the third aim, that is volume of gas liberated at the electrodes. So we are going to use the same formula that we have used when we are determining the mass of substance deposited, but the difference here will be in the formula. Where we were dealing RAM, we are going to put the molar gas volume. That's the only difference. So let's go and check the formula used. The formula used when we are calculating volume of gas liberated will be V, which is equal to Q multiplied molar gas volume divided by N times F. If you remember, when we were calculating the mass of substance deposited, the formula was Q multiplied by RAM. So here, the volume will be Q multiplied by molar gas volume instead of RAM, then divided by N times F. So we're saying where Q is the quantity of electricity passed, and remember Q can be obtained by using the formula IT, where I is current, which is measured in amperes, T is time, which must be in seconds. So we're saying here volume is the volume of the gas liberated. That's what we are calculating. So here N will be the number of electrons gained or lost. In other words, number of Faradays. F, that's Faraday, it's equal to 96,500 coulombs. Then lastly, MGV will be the molar gas volume. It will be given in the bracket, just like the RAM. We go examples. Example number 1. We are told what volume of oxygen liberated at the anode when a current of 3 amperes is passed through magnesium sulfate solution for 45 minutes and 30 seconds. So in bracket, molar gas volume at RTB is equal to 24.0 liters. Faraday constant is equal to 96,500 coulombs. So we are going to start by looking Q. Q is equal to IT, where I is current measured in amperes. That's 3 multiplied by T, time. And we say time must be in seconds. So when we check here, we're having 45 minutes and 30 seconds. So we have to take 45, then multiply by 60 to convert it into seconds. And we are going to add 30 seconds. So here we are going to get 3 ampere multiplied by 2730 seconds. What we are going to get is 8190 coulombs as our quantity of electricity passed. So V, that's the volume of oxygen liberated, will be equal to Q, which we have gotten 8190 multiplied by molar gas volume. The molar gas volume is given in the bracket. That's 24.0 liters divided by N. So N here is the number of Faradays. So how are we going to know? Let's know first of all our electrolyte. Our electrolyte here is magnesium sulfate solution. That means it is non-binary electrolyte. So when it decomposes, it produces 4 ions, 2 cations and 2 anions. So the 2 anions are sulfate ion and also hydroxyl ions. So when we are doing differential discharge, we said hydroxyl ions are preferably discharged over sulfate ions. So that means hydroxyl ions are the ones losing electrons to form oxygen gas and also water. Then electrons are lost. So when we balance this equation, we are supposed to put 4 in the side of the hydroxide side. Then we are going to put 2 in the side of the water. Then that means 4 electrons are lost. So that means the number of Faradays, or our N, will be equal to 4. It will be equal to 4 multiplied by F, and F we say it's Faraday constant, which is equal to 96,500 coulombs. That's how we are going to get. Then when we put all this in the calculator, what we are going to get will be 0.5092 liters. You can leave your answer in liters, or you can multiply by 1000 so that you convert into centimeter cube. So we can get 5092 centimeter cube as the volume of oxygen liberated at the anode. Question number 2. We are told calculate the volume of chlorine gas in centimeter cube that is formed when a current of 0.9 amperes is passed through a solution of concentrated sodium chloride for 30 minutes. And we are told 1 mole of gas at STB is 22.4 decimeter cube and 1 Faraday is equal to 96,500 coulombs. So what we are going to use is the formula. Volume is equal to Q, which is the quantity of electricity mass, multiplied by mgv, that's the molar gas volume, divided by n times F, where n is the number of Faradays and F is Faraday itself. So V will be equal to 0.9, that's the current, multiplied by time. The time here is 30 minutes, but you have to multiply by 60 to convert it into seconds. So the first bracket we are in with is Q. Next, multiplied by molar gas volume. The molar gas volume given here is 22.4 decimeter cube, but we are told you have to give the volume in centimeter cube, so we can multiply it by 1000 there, divided by n. So what will be the n? N will be 2. Why? Because we are dealing with chlorine. That means chloride ions at the anode will be losing electrons to form chlorine gas. So that means if we balance, we are going to put 2 there. Then what we mean is we have lost 2 electrons. We have lost 2 electrons. That's what it means. So the number of Faraday will be 2. That is the 2 we have there, multiplied by F, that's Faraday, which is given in the bracket. That is 96,500 coulombs. If we put all this in the calculator, we are going to get 188 centimeter cube as our volume of chlorine gas. Question number 3. We are told in the extraction of sodium from sodium chloride, a current of 3.4 ampere was supplied for 8 hours. Then we are asked to calculate the volume of chlorine that was evolved at room temperature and pressure. 1 Faraday is equal to 96,500 coulombs, and 1 mole of gas at room temperature pressure, RTB, is equal to 24,000 centimeter cube. So the formula is V will be equal to Q multiplied by molar gas volume divided by N times F. So V will be equal to Q. Our Q will be, we're having 3.5 as our current. So here is 3.5, not 35, 3.5 multiplied by 8. That's the time, 8 hours. So we have to convert it into seconds. So we multiply by 60 to convert it into minutes. And we multiply another 60 so that we convert it into seconds, multiplied by the mgv, the molar gas volume, which is given 24,000 centimeter cube, divided by n, that is the number of Faradays. Remember, we are talking about chlorine. So what we are going to see is that chloride ions at the anode will be losing 2 electrons to form chlorine gas. So the 2 electron that has lost is the number of Faraday, or our n. So we are going to put 2 here multiplied by Faraday, that is F. F will be equal to 96,500 coulombs. So when we put all this in the calculator, we are going to get 12,535 centimeter cube as our volume of chlorine that was evolved at room temperature. So next we are going to go to the extended question. We have 2 extended questions, so kindly try it and you can submit your response or your answers in the comment section. I will be responding to you inshallah as soon as possible. Thank you for watching.